Today we're going to talk about quantum physics, and this will be our subject for quite a while now. In essence, we're going to be working on the equivalent of Newton's laws for a particle's motion, but adapting to the case when we're talking about de Broglie waves, not just ordinary particles that we're used to. So the kinds of Newton's laws that we're going to have to write down are going to be quite a bit different than F equals ma. This actually had an interesting start to it because Schrödinger was giving a lecture on de Broglie's wave hypothesis and how this gave stationary states in the Bohr model. But another physicist listening to his lecture actually made a very interesting comment. He said that such a thing was childish because real waves, waves that we're familiar with from electromagnetism or waves on a string, all have a wave equation. Once Debye said this launched a series of studies for Schrödinger on how to find such a wave equation, or the analog to Newton's laws. For particles of any sort, from Broglie we have that P is h over lambda, or sometimes written as h bar k. We also have that the energy of a particle is h times frequency, or h bar times omega. The second, of course, started out just for photons, but now we've postulated it to be true for all particles. So how do we write down an equation for a wave which just allows us to solve general problems? So all wave equations are built out of some sort of physical law. And one idea would be that this would just express the total energy of a particle. That the total energy is kinetic energy plus potential. Of course, this is non-relativistic. And in fact, if you want a relativistically correct version of quantum mechanics, this would not be a good starting point. You'd have to use our more familiar formula from relativity, which relates to the square of energy, the square of momentum, the square of mass. But Schrödinger started out with a non-relativistic expression. In terms of our quantum quantities, this would give us the following expression. So we're looking for some sort of wave equation that will ultimately yield this kind of relationship between omega and k. And we'll also have to keep in mind that the wave function that we're ultimately going to be looking for to satisfy this wave equation has something to do with probability.